We will now begin today's presentation and would ask that we move to slide 2. So as a first step, we'll begin by introducing ourselves. I have already introduced myself as the moderator of the session, but for those that may have missed it, my name is Candida Chinchi, and I'm the Director of the Canadian Nuclear Laboratories Regulatory Program Division. I am joined by my colleagues Eric Lemoyne, Director of the Transport Licensing and Strategic Supporting Division, and François Dagenet, Transport Officer, also within the Transport Licensing and Strategic Support Division. This slide shows the key messages of today's presentation, and the following are the points we hope you take away from this webinar session. The first being that the transport of radioactive waste is carried out safely in Canada. The overall safety record of the transport of nuclear substances, which includes radioactive waste in Canada, has historically been excellent. There have never been any serious injuries, overexposure, fatality, or environmental consequences attributable to the radioactive nature of such material being transported or being involved in a transport accident. The safety record of radioactive material shipments is backed by a stringent regulatory regime that has been in place and under continuous review for more than 60 years. The CNSC works in conjunction with other regulatory bodies to ensure the safety of all radioactive materials in transit, and the CNSC, alongside Transport Canada and the provinces, has regulatory oversight of the transport of all radioactive waste in Canada. The purpose of today's webinar is to provide a general overview of how the transportation of radioactive waste in Canada is regulated to ensure safety of the public and the environment. We will provide an overview of the roles and responsibilities and regulatory requirements for the packaging and transport of radioactive materials in Canada. We will also discuss the requirements for packaging and shipping of radioactive waste, how CNSC staff ensures compliance, as well as whether and how the transportation of radioactive waste applies to the proposed near-surface disposal facility, or NSDF project, and in situ decommissioning projects, herein referred to as ISD. This slide situates us in terms of where we are in the fall webinar series that the CNSC is hosting with respect to the NSDF and ISD projects. As you can see, we will be hosting a series of webinars related to these projects. The webinars are designed to present general information on topics listed, followed by a dialogue and answering questions participants may have on the specific topic covered. Registration is now open for the remaining webinars listed, and we encourage you to sign up. We will circle back to this slide later on in the presentation with more information on these webinars and how to register. We'll begin with project updates on the NSDF and 2 ISD projects. First, an update on the NSDF project. CNL submitted a revised Final Environmental Impact Statement, or EIS, on May 28, 2021. The revised EIS was reviewed by staff to determine if it addresses staff's feedback provided in January 2021, which is available on the public registry. CNSC staff determined that all of staff's concerns were addressed, and the revised final EIS was accepted on July 2nd, 2021. CNL was notified of this decision on July 8th, 2021. All of the environmental assessment and licensing documents were also deemed acceptable on July 8th. The final EIS, along with the disposition tables, that is, the consolidated tables which contain CNL and CNSC staff responses to formal comments received on the draft EIS from members of the public, Indigenous groups, non-governmental organizations, and other stakeholders, and the federal provincial review team's comments on the draft EIS and other relevant documents have been posted to the Canadian Impact Assessment Registry, which can be accessed via the link on this slide. These documents are available in both official languages. On July 8th, CNSC staff also informed the Commission Secretariat of the completion of the environmental assessment and licensing regulatory review, as well as staff's readiness to proceed with the preparation of the licensing commission member document and the environmental assessment report. The NSDF public hearing dates will be established by the Commission Secretariat, and a notice of hearing issued on our website and to our subscriber list. Once available, CNSC staff will also distribute this information to the NSDF project-specific distribution list. Moving now on to the NPD and WR1 projects, CNL is planning to submit a revised draft environmental impact statement and responses to federal and provincial review comments for each of the NPD and WR1 in situ decommissioning projects by the end of October and December, respectively. Upon passing completeness verification, the revised EIS and responses will undergo a technical review by the federal, provincial, and Indigenous review team. Project updates can also be found in the project bulletins that are distributed to the NSDF, NPD, and WR1 mailing lists, as well as feature articles that are posted on the CNSC's website. The latest round of feature articles for the 3 projects will be posted shortly. We'll now transition to the key topic of this webinar, the transportation of radioactive waste, starting with a general overview of the roles and responsibilities and regulatory requirements. For this, I will turn the presentation over to Eric Lemoyne.
Thank you, Candida, and welcome everyone. My name is Eric Lemoyne, and I'm the Director of the Transport Licensing and Strategic Support Division. The CNSC regulates the transport of nuclear substances through a series of regulatory requirements covering the entire journey of a shipment, from the time it's initially packaged to arrival at its destination. Canada is a producer of nuclear substances, and consequently, it's also a shipper of nuclear substances. Each year, more than 1 million packages are transported in Canada, in addition to the shipment of nuclear fuel cycle products, such as uranium ore, fuel bundles, and uranium hexafluoride. The transport of nuclear substances involves the carriage of nuclear substances for industrial uses, medical uses, research, and for the management of radioactive waste. At the federal government level, the responsibility to ensure the safe transport of radioactive material is jointly shared between the CNSC and Transport Canada. While Transport Canada's regulations deal with the transport of all classes of dangerous goods, the CNSC's Packaging and Transport Nuclear Substances Regulations 2015 are primarily concerned with the protection of the health, safety, security of the persons, and the environment with respect to special characteristics of radioactive material, otherwise referred to as Class 7 dangerous goods. The CNSC's Packaging and Transport Nuclear Substances Regulations 2015 provides reference to the latest edition of the International Atomic Energy Agency, or IAEA, regulations for the safe transport of radioactive material, currently the 2018 edition. Note that all industrialized countries use the IAEA transport regulations as the basis to regulate the packaging and transport of radioactive materials. Next slide, please. CNSC and Transport Canada work together with the provincial and municipal authorities. Both Transport Canada and the CNSC regulations apply to all persons who package, transport, and receive radioactive material, whether these persons are licensed by the CNSC or not. An updated memorandum of understanding between Transport Canada and the CNSC, signed in June 2019, coordinates the activities of each agency to minimize and/or eliminate duplication and overlap. Each group is expected to carry out their own mandate while supporting each other so as to achieve common goals. It is the responsibility of Transport Canada to oversee the transport of all classes of dangerous goods, including Class 7 radioactive materials. Transport Canada regulates in accordance with the Transportation of Dangerous Goods Act 1992 and the Transportation of Dangerous Goods Regulations, otherwise referred to as TDGR. Those who transport or present for transport nuclear substances must comply with CNSC's Packaging and Transport Nuclear Substance Regulations 2015 and the Transport of Dangerous Goods Regulations. We'll now move on to discussing requirements with respect to packaging that manages the risk and ensures safety in the transport of nuclear substances. There are multiple layers to ensure safety: international requirements, domestic requirements, and specific licensing in some cases for higher risk material. Nuclear substances must be transported in very specific packaging, of which there are different types. The basic premise of transport is that safety relies heavily on the design of the package. The design requirements for the package are commensurate with the risk posed by the substance being transported, with higher risk material requiring more robust packaging. To be certified by the CNSC, certain packages must meet stringent performance criteria for shielding, containment, ability to withstand impacts, ability to withstand heat, and more. Package designs are combined with additional regulatory controls, including labeling, placarding, quality assurance, and maintenance records, allowing nuclear substances to be carried safely in all modes of transport, such as road, rail, air, and sea. The CNSC regulates all aspects of the packaging and transport of nuclear substances, including the design, production, use, inspection, maintenance, and repair of packages. There are exemptions currently in place under the Packaging and Transport Nuclear Substance Regulations 2015, which include persons who have undergone medical treatments, certain consumer products once sold to consumers, such as smoke detectors, and radioactive material that is a component of a transport vehicle, such as depleted uranium counterweights used in some aircraft. When the radioactive material does not fall under any exemptions, the material needs to be transported in one of the package types defined in the regulations, based on the nature and the quantity or activity of the substance to be transported. There are general design requirements which apply to all packages to ensure that they can be handled safely and secured properly during transport. The lowest category of packages under the regulations is the accepted packages, which may contain very small amounts of radioactive material. An example of their use includes the transport of smoke detectors. These are followed by industrial packages, which are designed for the transport of low specific activity material, such as uranium ore and concentrates, and surface contaminated objects, such as pumps or contaminated tools, for example, used at power reactors. Then there are type A packages, which can carry small amounts of nuclear substances, such as medical isotopes. Neither the industrial nor the type A packages require CNSC approval. These are referred to as pre-approved or accepted packages, meaning that the responsibility for meeting the regulations rests with the user of the package, who must be able to demonstrate that the package meets the regulatory performance standards set in the regulations. Compliance verification is done by CNSC inspectors while conducting inspections. Packages designed for the transport of higher risk levels of radioactive material require certification by the CNSC before they can be used in Canada. The types of packages that require certification by the CNSC are type B, C, and H packages, and packages designed to contain fissile material. These packages are designed to transport nuclear substances such as cobalt-60, sealed sources used for industrial radiography, used nuclear fuel, and enriched uranium. This slide shows examples of accepted packages, which may contain very small amounts of radioactive material, industrial packages for the transport of material such as uranium ore, and type A packages, which can carry small amounts of nuclear substances such as medical isotopes. These are just examples of packages. It's important to note that for any type of package, some can be small and some can be very large. This slide shows examples of type B packages, which must be certified by the CNSC. Type B packages include radiography cameras, as well as packages used for shipments of bulk medical isotopes and tritiated heavy water. Packages requiring certification have to undergo stringent testing, which must simulate both normal and accident conditions of transport. The tests can include free drop testing, puncture testing, thermal testing, and aircraft accident simulations. This slide shows the different types of tests that packages need to go through to demonstrate they are fit for service. Type A and Type IP3 packages are designed and tested to withstand a series of tests that simulate the conditions of normal transport. These tests include a water spray test, a drop test of a height of 1.2 meters, a stacking or compression test, and a penetration test with a 6 kilogram bar drop from 1 meter in height. All Type A packages must pass these tests prior to use so as to ensure their integrity and safety in transporting radioactive substances. Type B radioactive packages are designed to withstand a more stringent series of hazards compared to Type A packages without breaching containment. These tests are designed to simulate major accidents during transit. Type B packages are designed to withstand drops from a height of 9 meters or roughly 30 feet onto a flat, unyielding surface, as well as a drop from 1 meter or roughly 3 feet onto a punch bar or pointed surface without breaking. They're also designed to withstand a constant temperature of 800 degrees Celsius, roughly 1,470 degrees Fahrenheit, for a duration of 30 minutes. And they are designed to withstand immersion in 15 meters of water, approximately 50 feet, which subjects them to pressure of 2.5 bar or roughly 36 pounds per square inch. All these tests are developed to protect the contents from escaping should the containers ever be involved in accidents during transit. All Type B packages must pass these tests prior to use so as to ensure their integrity and safety in transporting radioactive substances. Type B packages are used to transport material with high levels of radioactivity. Some are small, and some which are used to transport used nuclear fuel, for example, can weigh more than 100 tons. As this presentation was sent out to all the registrants from today's webinar, these links are available to you. They visually demonstrate some of the tests that have been conducted on various package types and the conditions they are required to withstand. We encourage you to view them at a time suitable to you. We will now discuss the requirements for shipping of radioactive substances. For this, I will turn the presentation over to Monsieur François Desgenais.
Thank you very much, Eric. Good afternoon, everyone. As mentioned, my name is François Desgenais. I'm a transport officer with the Canadian Nuclear Safety Commission within the Transport Licensing and Strategic Support Division. So first, I'd like to apologize for not turning on my video, but it is currently not working. So unfortunately, I'll have to do the presentation without video. So for preparation for shipment, so the prime responsibility for ensuring safety of the nuclear substances during transport rests with the consignor. So the consignor is the person who prepares the shipment for transport. So he's responsible for characterizing and classifying the nuclear substances. That's determining exactly what is transported and what will be transported, classifying in accordance with the transport regulation, nuclear substance. He must then select an appropriate package for that material, load the package, and secure the package appropriately. Consignor must also ensure that the shipment itself complies with all regulatory requirements specified in both the CNSC regulations, which is the Packaging and Transport Nuclear Substance Regulations 2015, and the Transport Canada regulations, which are the Transportation of Dangerous Goods regulations. So this basically includes ensuring that all employees that are involved have been adequately trained as per their function. Appropriate safety marks are displayed on the packages as required by the regulations. Transport documents are completed and accompany every shipment of nuclear substances. And the vehicles transporting the packages display the appropriate safety marks when required. Right? So those are the placards. The person who carries the shipment, so the carrier, so again, they must ensure that all persons involved, right, all of their employees have been trained according to the regulations. Okay, and they must also ensure that the package are properly loaded and secured in the vehicle. Okay, they must also ensure that all appropriate safety marks continue to be displayed during transport. So now we'll move on to the emergency response side of things. So nuclear emergency preparedness and response, okay, is a multi-jurisdictional responsibility in Canada. So that's shared by the federal, provincial, and municipal government, as well as our licensees, so the consigners. Now, first, so Transport Canada regulations requires a 24-hour number be displayed on all of the transport documents that accompany shipments of radioactive material. The person answering that telephone must be able to provide technical assistance to any emergency responders or anybody requesting assistance or technical assistance with regards to the shipment. In addition, as you can see on the slide, the emergency response guidebook, which is published. So that's the orange book on the side. So that's the emergency response guidebook. It's a North American publication. So in Canada, it's published by Transport Canada. And they ensure that a copy of this book is available in every single emergency vehicle, so first responder vehicle in Canada. And precisely the first responders fire department vehicle. So the book is available in hard copy through Transport Canada. They do provide it to first responders free of charge. You can also download an app for your phone or for a computer if you prefer an electronic version. So Transport Canada also operates Canutech, which is an emergency response center. So they're also available 24 hours a day. So they do have a phone number that can be called by any person, typically first responders, that can call the center for any type of advice involving any shipment of dangerous goods, including radioactive material. So when incidents involving radioactive material in transport are reported to the CNSC, so a transport officer or certification engineer, so someone from the transportation division will follow up on the incidents. Their role will be to provide technical information and advice to the person in the field who are responding to the incident. We also have CNSC duty officers, which are available 24/7, okay, that can also provide guidance to first responders and persons involved in the remediation of any type of accident involving radioactive material. And if need be, CNSC staff can go on site if required to provide assistance with managing the situation. However, it should be noted that CNSC staff are not first responders, so typically we don't necessarily attend accident scenes. So next slide. So emergency response assistance plan. So under the Transport Canada regulations, for certain types of nuclear substances, radioactive materials, consignor is required to have an emergency response plan in place prior to shipment of the material. Okay, so this is called Emergency Response Assistance Plan, or in short, ERAP. Okay, so an ERAP essentially describes what they will do in the event of a release or anticipated release or any type of incident involving their product. Now, plan has to be approved by Transport Canada before any shipments can take place. So just before we move on to the next slide, just a some sort of, I guess, a warning, if you wish. So we will show an image of an actual motor vehicle accident. So I just want to warn people that find these types of images disturbing, to be on your guard. So if you wish not to look or turn or to mute for a short period of time, please do so. So there have been very, very few accidents involving or serious accidents involving radioactive material in Canada. But there have been one or two. So this is an example of one of those accidents. So it was an accident that occurred in 2001. So it was a collision between two tractor trailers that occurred on Trans-Canada Highway near Dryden, Ontario. So one of the two vehicles was transporting two Type B packages. So as you can tell, the two vehicles basically just collided head on. Vehicles caught fire right away and basically burned to the ground. So CNSC inspectors were requested to attend the scene, okay, just to provide some sort of guidance to first responders. So now, although the fire lasted for a few hours, both packages were basically found by the first responders and were not affected by the accident. So there was no release of content, or there was no increased surface dose rate on the package. So the integrity of the Type B packages was essentially not compromised. So basically, this is we just wanted to illustrate that packages used to transport radioactive material are very sturdy, okay, and the packages used for the high risk sources are essentially designed to withstand these types of incidents. All right, so we can move on now to the next slides. So what we'll do now is we'll be discussing how CNSC ensures compliance with the transport regulations. So CNSC inspectors ensure compliance with our regulations, so the Packaging Transport Nuclear Substance regulations and the Transport Canada regulations. So inspections are conducted at licensees' facilities, so the consignor facilities. Inspections are also conducted at non-licensee facilities, so essentially at the carrier facilities. So typically our inspections target major licensees, okay, established at the planning stage using a risk-informed approach, okay, for calculating the frequency of inspections. So CNSC does use a graduated enforcement approach, okay, for the implementation of corrective measures by licensees and carriers in response to items of non-compliance found during compliance inspections. So just wanted to note as well, so CNSC also hosted a webinar in both English and French, okay, which further detail our compliance verification procedures. So the webinar was hosted on May 20th, 2021, and will soon be available for viewing on our YouTube channel. So this is just an example of the types of non-compliances that we may notice. So this was issued to CNL after an inspection activity. So during the inspection, CNSC inspectors observed that the vehicles, so the trucks transporting waste, did not have the correct signage on them. So the placards displayed on the trucks weren't exactly the prescribed placards. So CNL was issued a notice, okay, that required them to address the deficiency. CNSC inspectors then confirmed that the actions taken by CNL or actions were taken by CNL and that the non-compliance was corrected. All right. So finally, so CNSC has reporting requirements within the regulations, okay, which applies to carriers and consigners. So carriers and consigners are required to report to the CNSC essentially all vehicle accidents, okay, and they're also required to report any damage to packages that are sustained during transport. So CNSC does report these events in the various regulatory oversight reports that we have. So So essentially, so the documents, the oversight reports are listed in CNSC or oversight reports, which are presented to the commission on an annual basis. So in summary, safety records of radioactive material shipments is supported by a stringent regulatory regime that has been in place and under continuous review for more than 60 years. So while a small number of packages may be involved in transport-related incidents every year, the overall safety records of transport of nuclear substances in Canada has historically been excellent. There has never been any serious injuries, overexposure, fatality, or environmental consequences attributable to the radioactive nature of such material being transported or involved in a transport accident. So I will now turn the presentation back over to Candida.
Thank you, Francois. We will now describe the applicability of the activity of radioactive waste transportation as it relates to the proposed NSDF and ISD projects. The transportation of radioactive waste does not apply to the NPD closure and WR1 decommissioning projects, as no waste is proposed to be transported to these sites as part of the in situ decommissioning approach. Each site will ultimately become a sealed disposal facility with no possibility of adding any additional waste to the facility. In situ decommissioning of the NPD and WR1 sites would not require the transport of radioactive waste, as the waste currently present in these facilities will be entombed, thus eliminating the need to remove and transport it. For clarification, it should be noted that the White Shell Laboratories site currently has an active decommissioning license, which is separate from the proposed White Shell Reactor 1 decommissioning project that CNL has applied for. Radioactive waste is periodically shipped from the White Shell Laboratories to CNL's Chalk River site. These shipments are subject to the same rules, regulations, and conditions, as any other shipment of radioactive substances within Canada. Specifically to the NSDF project, approximately 90% of the low-level radioactive waste proposed for the facility was generated on the Chalk River Laboratories, or CRL, site, and is already located there. A small percentage of waste is from other Atomic Energy of Canada Limited sites, such as the White Shell Laboratories site in Manitoba, approximately 5%, or from third parties, primarily Canadian hospitals, universities, and isotope suppliers, with another approximate 5%. Transport of waste to the CRL site in general, and specifically waste that would be accepted for emplacement in the NSDF, provided it meets the Facility Waste Acceptance Criteria, or WAC, is out of scope of the NSDF project for two reasons. The Packaging and Transport Safety and Control Area covers programs for the safe packaging and transport of nuclear substances and radiation devices to and from a licensed facility. It does not cover programs for the safe packaging and transport of nuclear substances and radiation devices within the same site, that is the NSDF and the remainder of the CRL site. And the second reason is that the current application by CNL is only to construct the NSDF and does not include activities to transport off-site waste to the CRL site for emplacement in the NSDF. As we committed, further information on each of our upcoming webinars with respect to the NSDF and in situ decommissioning projects is found on this slide. Registration is available through the CNSC main webpage, but for ease of reference, we've also included the registration link on the bottom of this slide. And we really hope to see you all there. This concludes our presentation.